Hi, today I want to talk about how to use trig substitution to evaluate integrals here. So let's take a look at this example. You have x squared in the denominator and then another square root of x squared and then plus 1 in your square root. So now we are going to use trig substitution to solve this integral. So basically, when you see x squared plus 1, and then you can think about some formulas that you have memorized. So something that can give you a 1 in here. So something like x squared plus, sine square plus cosine square will give you 1. And also let's think about 1 plus tangent square will give you secant square. Or 1 plus cotangent square will give you cosecant square. So in this examples, we are going to set x equal to tangent theta. Then dx will be the secant square theta. This is something you need to memorize, how to the derivative of tangent theta. So now let's bring x tangent theta into our formula, into our integral. And then we have something like this. So we have tangent square plus square multiplied by square root of tangent square plus 1. So like I said, tangent square plus 1 is basically just secant square. So now we can substitute this part into secant square. And also notice that we need to rewrite dx. So dx is just secant square d theta. So we put this part in at the end to substitute dx here. So this is your how you rewrite the original function by substituting x equal to tangent theta and dx equal to secant square theta d theta. So after you cancel out the similar terms, and then you get secant theta over tangent square d theta. So remember that secant theta is just the inverse of cosine theta, and then tangent theta is just sine divided by sine over cosine. So by substitute substitute these into this part, you just to rewrite it into a cosine theta over sine square. You can also solve this function if you are familiar with the integral of these, but just in case, to make it to a even simpler equation, you can rewrite this in terms of cosine and sine. So basically, you can see that it is the power of 1 in the numerator and power of 2 in the denominator. So basically, it's the same thing, but it just we use another we use sine and cosine to rewrite tangent and secant here. So that so now let's use integral of by substitution. We set u equal to sine x, sine theta, and du is basically just a derivative of sine theta, and that is cosine theta. Well, for everything on my side notes, on the side, that is something you need to memorize, and then you need to be very good at it to evaluate. So basically, this is something you need to memorize, and this is the technique. So you need to memorize all the formulas here in order to have a technique to solve a complicated integral here. Okay, so now let's come back to here. So cosine. So let's if we set u equal to sine theta. So basically, this thing become 1 over u squared. So this will be very easy to evaluate. So basically, just the negative of 1 over u plus a constant here. So remember, so this is your solution in terms of u. However, our original question is based on Okay, okay. So back to here. Our original question is defined by theta. So we need to substitute u back to rewrite our solution into theta first, and then we will later rewrite it back from u to theta and then to x. Okay, so now let's rewrite it back to in terms of theta first. So plug in that, and it will get negative 1 over sine theta plus a constant, and 1 over sine is just a cosecant here. Okay, so the rules we have used so far is that when in our question we have a square root over x squared plus 1, well, we can generalize it into a squared plus u squared. So basically that is just 1 plus x squared. So in our question, it's just 1. In our example, it's just a is 1 and then u is x here. So if we have something like x squared plus, let's say 4, that is 4 is just a square of 2. So and then we can substitute u as 2 times tangent theta. But here, since a is 1, so we substitute x equal to 1 multiplied by tangent theta. But to generalize it, we can set u equal to a times tangent theta. So in this case, we can rewrite the square root into a square multiplied by 1 plus tangent square. Since tangent square is just is secant square, so basically in your square root you have a square secant square. So that would just give you a secant theta. Similar, if you have if in your denominator you have something like a constant minus x squared, set u equal to a times sine. So basically, you can rewrite your square root in terms of 1 minus theta sine squared. So basically, that 1 minus sine squared is cosine squared. So that your square root will give you a times cosine. And another form is that u squared minus a constant. So set u equal to a secant theta, so that you can rewrite your square root in by a times secant square minus 1. So secant square minus 1 is actually just tangent. So 1 plus tangent square is secant square. So secant square minus 1 is tangent square. So your square root will give you a times tangent theta. Okay, so these are the rules and these are the formulas. You need to memorize it. And here is just the technique you apply. So make sure you memorize all the rules in order to help you to solve your integral. Okay, so far we have rewrite the integral from u to theta. The next step is that we need to rewrite the integral from theta in terms of x. Back to our original variables. So okay, so here the relationship between x and theta is that we set x equal to tangent theta. So okay, one more thing is that 1 over sine squared is just cosecant. So that this is our solution here in terms of theta. So now let's rewrite this in terms of x. Okay, so the relationship is x equal to tangent theta. So let's take a look. In a triangle. So tangent theta is equal to x. So basically, this is x over 1. So that so inside the triangle, tangent theta is x over 1. So it's just this side divided by this side, so that we can calculate that this is equal to x squared plus 1, and then take the square root. And then we can define a triangle. We can define the sides of this triangle based on what we set in here. So now we have a relationship between theta and x. So again, cosecant from our solution, cosecant is just 1 over sine x. Yeah, here 1 over sine theta. And then sine theta, it's just x divided by this, right? And then the inverse of sine theta, it's just sine squared plus 1, take the square root over x. So that can be substituted back to our solution here. So our final solution in terms of x is just negative x square root of x squared plus 1 over x plus a constant. So we substitute here from theta to x here. So this will be our final solution for this integral here. Okay, so basically we substitute twice here using trig substitution and then the regular substitution here, and then we finally rewrite our integral from u to theta and then to x, and this is our final solution. Okay. So again, here are the rules or the formulas that you definitely need to memorize it. So like I said here, these are the rules. You can pause the video and then take it down, or you can also look it up in your math book here. So the reason we set u equal to a tangent or a sine theta or a secant square is that we have this function here. So whenever you see a 1 under your inside your square root, think about something that you can get, either a sum or a difference to get the 1 here. So the formulas involved with 1, you can substitute into under your square root. Again, so sine square plus cosine square is 1. 1 plus tangent square is secant square. So secant square minus 1. Here, secant square minus 1, it is tangent square. 1 plus cotangent square is cosecant square. So so secant square minus 1 is cotangent square. Okay. So make sure you understand, memorize the formula first. Very important. Memorize everything, and then apply this these either rules or the formulas into as a technique to solve a more complex integral. So thank you very much, and let me know if you have any question.